So a bit about myself. It was a great introduction, Nico. Thank you. As you may have picked up from my accent, I'm Australian, living in Switzerland for the last 12 years almost. I've been working in InfoSec for over 20 years, including some times as a teenager when it was more of a hobby. I've been writing about OSINT for quite some time, various different blog posts. And as Nico mentioned, I've been working on SpiderFoot, actually going back to 2005. So it's a little bit of a lie that the 10 years lessons learned, it's a bit more than that, but SpiderFoot has its own story. I won't get into that too much here, just to kind of give you an overview of SpiderFoot in case you don't know what it is. It's a OSINT platform, basically. It's an automation platform. It's typically used in the kind of cybersecurity space, you could say, right, for threat intelligence and attack surface management, but I know it's used much more broadly than that. It is open source. There is a cloud SaaS version available, a commercial version, but also has a free tier if you want to give that a shot. There's over 200 modules in SpiderFoot, and what that means is there's many different data sources it integrates with, many different things it does to that data to kind of give you value and give you something that you can work with. It's been in development, like I mentioned, over 10 years, a bit longer than that, with a bit of a hiatus in between. But yeah, there's a lot of lessons learned baked into the software. It has 7,500 stars so far on GitHub, version 4 is actually out today with some cool new features. So I encourage you to check that out. So when I talk about automating OSINT, it's probably worth clarifying what I actually mean, because I think it means a lot of different things to different people. So the first key step is kind of data collection, right? And so when we talk about data collection, we're talking about the manual task of kind of identifying what data sources you want to use, what APIs you want to query, maybe what websites you want to scrape, all these types of things. So there's quite a lot of work that can go into the data collection phase. And that's probably where, if you look at a lot of tools out there, that's where a lot of the automation is. It's kind of, going out and just collecting a mass amount of data and then giving that to you to work with. And then there's a stage what I consider like entity extraction. And when I say entity extraction, I'm talking about getting that content that you've pulled down automatically and extracting phone numbers, email addresses, anything that you're kind of interested in. I consider these kind of entities of data to work with. And then the next stage is processing. And by processing, I mean, you're sorting, you're filtering, you're enriching, you're analyzing the data, you're doing something with that, and then probably resulting in actioning, right? So you kind of, if you look back to the beginning of this process, you have identifying the data sources you want to get, through to extracting and analyzing it, and then actually doing something actionable with that data. And underpinning all of this is basically the technology, right? So to automate things, you usually need to use some form of technology. Maybe, on one end of the spectrum, it might be Excel in some way, right? What my experience is with is more on the software development side, like building tools that have a bit of infrastructure, have a database, obviously have some code, and maybe some additional tooling around that to support that process. And then automating OSINT, it's kind of cyclical, right? So you have the data collection, you do the entity extraction, do some processing, but maybe then you might feed that back into the beginning of the process and repeat that all over again to do some further analysis. This is what I would consider iteration, and I'll get to that in a later stage of the presentation. So let me talk through a concrete example, right? So the most basic thing of automating OSINT, let's say, is kind of downloading a web page to extract email addresses, right? You have a target, you want to say, okay, I want to get the web page and see what email addresses are on that web page. Maybe it's the front page, maybe it's a contacts page, something like that. But then to take that to the next level, you might want to crawl the whole website, right? So you might kind of look for all the links, then follow those links and kind of do your own little mini search engine to bring down all that content and extract email addresses. And then to take that even further, you might get those email addresses and you might query an API, right? Like maybe it's have I been pwned or something like that, where actually you want to see if those email addresses appear in a data breach. And you can think of this also from a defensive perspective where, okay, actually want to do something with these results, right? So we've got the email addresses, we've found which ones have appeared in the data breach. And maybe then we want to export that to Excel, CSV, JSON, something so that we can actually work with it further and do some filtering and analysis. And then the ultimate stage is, okay, well, actually, I want to do this process automatically, maybe on a daily basis, right? So those of you familiar with Linux, you might set up a cron job or something where you do this whole process on a daily or weekly basis. and you can maybe notify your security team or maybe the individuals involved and say, hey, your email address has appeared in this data breach. And we found your email address because it's mentioned on our company website, or maybe you're not crawling the website, maybe you're consulting an internal system within the company. Even then, it's still OSINT automation from my perspective. So this is what I consider a simple example for OSINT automation. So I'll quickly talk about the technology. I won't spend too much time on this because I think there's much more to be talked about in other parts, but I think it's worth mentioning. Again, this is my opinion. I'm sure it's going to generate a lot of rage in the room for people who are stronger with other languages, but I'm still a believer that Python reigns supreme in the OSINT automation space for a number of reasons. I think, like, one, it's still highly popular, right? Like, you can easily find people who can develop Python. There's a huge community around Python. It's cross-platform. It runs on Linux, Windows, Mac, probably others as well. It's very easy to learn, in my opinion. I do have a programming background before I learned Python, but it was still like it's a very syntactically simple language to learn, and I think you can be very productive very quickly. There's a lot of libraries actually that exist with Python that enable you to, again, be very productive, but also from an OSINT perspective. Like the phone numbers library, for example, already has a lot of logic for passing out phone numbers from data. Beautiful Soup is a library that enables you to really easily scrape web content or analyze web content that's been scraped. Exifread, a great library for looking at metadata from documents and images, for example. So these libraries are all readily available and super useful. And then it's fast enough, right? Like, people will criticize and say, oh, Python is maybe not as fast as Golang or whatever, but it is fast enough for what you're going to do when it comes to OSINT. Like OSINT, when you're automating that, your bottleneck is typically going to be on the data you're collecting, right? So you're connecting to a data source, you're doing some analysis. So the delay is typically going to be on the network connection, the latency, the bandwidth, waiting for the processing to happen on maybe the API source you're querying. So that's where the delay is typically going to be. It's less likely to be on the processing side of the code you're writing. And of course, you can consider alternatives as well. I see that, especially like Golang. I looked at that a while ago, and I thought it was kind of lacking with some of these libraries, but I see it's actually come a long way since then. Ruby, I know there's some popular tools that have been written in Ruby as well. And of course, if you really want to, you can write in Shell, although I would not recommend that for various reasons. So I think it's worth mentioning that Linux and Docker are really worth learning. I've been working on Linux for quite a long time, and actually, when I first wrote SpiderFoot, it was in 2005. I wrote it in C#, and it was a Windows desktop application. And what I found when I eventually rewrote it in Python and rewrote it more focusing on Linux, there's such a rich set of tools that enable you to be really productive on Linux. And when it comes to OSINT automation, because you're doing a lot of this kind of querying data sources, analyzing the data, extracting different fields and things like that, Linux really lends itself well to this type of work. And I find there is a learning curve for sure if you're not comfortable with the command line, but you can learn that. And you can also, you don't have to convert your whole system to Linux if you don't want. You can use VirtualBox and run Linux in a virtual machine. If you screw that up, you can just reinstall that. It's no impact to you. And something I learned a little bit more recently is kind of using Docker. I found Docker is super useful when you want to, if you have any tooling that you write and you want to deploy that somewhere and ensure that it's going to work consistently the way it's worked on your machine. Using that with Docker is a great way to achieve that. And again, you can run Docker on Linux, Mac, and Windows as well. Good. So I think, maintenance is an often overlooked thing, and I'm guilty of that myself. If I look at earlier versions of SpiderFoot, the code is definitely not something I'm super proud of. And I think that was from this idea that I can write the tool and it's kind of it will serve its purpose, and then I won't come back to it. And then of course I did come back to it, and over 10 years I felt some of the pain from some of those decisions that I made early on. And I think it's very important to realize when you're automating OSINT, especially, it's very easy to kind of create that layer of tooling and then another layer of tooling on top of that, and so on and so on. And some of those design decisions from early on can really impact you. So it is important to think of the development process as a life cycle, and that you are going to have to invest time to maintain that and continually improve the technology. I would say a big thing is really think about the storage system that you're going to use for the tooling if you really want to use the tool over the long term. SpiderFoot uses, for example, a SQLite database, the open source version at least, and enables you to run SQL queries and do a lot of stuff with that data. If it was like in CSV files or just plain text files or something like that, it would be quite difficult to work with. So I would really recommend like giving thought to what database you're going to be storing that data in and how you're going to be working with it. It really pays off. And of course, there's many to choose from. I mean, SQLite is a very, very simple one. You have Postgres, MongoDB, Neo4j. These are all different types of databases, but you can use them depending on your use case. They're quite powerful tools. And scaling is, of course, another thing. So, you'll find often if a tool works and works well, you'll then say, okay, well, I ran it against this many targets. What if I ran against this many targets? Or what if I want to analyze this many entities? And you will run into scaling issues. So thinking through that question of how will this scale if I wanted to do this, 10 times more, 100 times more, is a valuable thought exercise to go through at the beginning. So I'll move on to data collection now. This is kind of where I think a lot of OSINT automation is typically focused. There are two ways I look at OSINT automation and data collection in particular. So I think of it as basically you can do active or passive. So there's really two sides to the coin. And active means, okay, you're scraping the website of the target. You might be doing some port scanning. You might be doing some DNS queries or vulnerability scans. You're really talking directly to the target and extracting the information from that target. And then you do the passive approach, which passive means, okay, maybe the target doesn't even know that you're actually targeting them and you're querying these third-party services that have already collected data on that target for you. Or maybe like social media, that target has provided the data to the platform and you're just getting the data from the platform. And I think with both approaches, they have their pros and cons, right? So we can talk about active collection first. And you have, of course, the advantage that the data is fresh. You're getting data directly from the source. There's no one in the middle. It can be very targeted. So you can target very specific systems and IP addresses and whatever else. And you have full control of that whole process. The negative side, of course, as I mentioned, is the target knows you're up to something, right? They're going to be looking, if they are monitoring their logs, if they do have systems that are looking for any kind of suspicious behavior or reconnaissance type of behavior, they will know that you're up to something. The work is on you to scale and maintain and pass and collect all the data, of course. You probably still have to do that, to be fair, on the passive side, but it's going to be much more on the active side. And then the data format and the content will change, right? So especially if you're scraping web content and doing things like that, whether it's from the targets, well, not on the target's website, but from a third-party website like social media and so on, those things will change and do so without warning because you don't have any kind of defined API. You don't have any kind of defined agreement with that entity from which you're collecting data. So that data will change and then your whole system will break and you'll need to very quickly make adaptations to be able to handle that new change. So that's important to note. I think it's also obviously very important to note that it might not be illegal in your jurisdiction, right? Or a violation at least of the terms of service. So there are definitely social media sites and other sites that say that scraping and doing all that type of stuff, like doing anything as a robot, is against the terms of service. We can argue about whether that's all legal or ethical or whatever. That's a different discussion, but it's just something to keep in mind. And so let's talk now about passive collection, right? So, we probably are familiar with some passive systems. I know Shodan is hugely popular, Census and Have I Been Pwned. These are really well-known services. And this is really about okay, you're querying an API, and that's usually a versioned and well-communicated, documented API. The data is well-structured. It's usually clean. Of course, there are bugs there as well. We'll get to that. And it's usually invisible to the target. So if you're querying a third party like Shodan, unless you're using specifically the API that triggers a scan, you are getting the data just from Shodan, and the target is probably not even aware that you're getting all this information about them. Of course, there's less overhead and maintenance. Someone else has gone through all the work of collecting the data, cleaning it, parsing it, structuring it, etc. But it does come with the downsides, right? And those downsides correlate neatly to the upsides of active collection, right? So the sharing of your data with a third party is an often overlooked problem. When you're querying a third-party API for, say, an IP address or a name, you are providing that information that entity, right? So maybe you trust Shodan or Centus or whoever, but it's something worth noting that when you query those systems, they probably have a log, they have some record somewhere that your system, your IP address, queried them for this particular IP address or name or something like that. So it's very important to keep aware of that, especially when you're dealing with PII, when you're dealing with sensitive, maybe threat indicators and things like that. Of course, the data may be stale or incomplete. Now, a lot of these systems are collecting data regularly, but it may be every 30 days, right? And especially in the world of cloud and whatever else, things change very quickly. So it's really important to keep that in mind. There might still be some legal implications, right? So not all of these third-party APIs are, I would say, 100% legitimate. Ones that have like data breach information, which reveal passwords, for example, that can be a legal challenge in some jurisdictions. And sometimes you don't have the transparency in how this data is being collected, right? So you don't know whether they've obtained data illegally. You don't know whether they've violated the terms of services of the systems that they're collecting the data from. Sure, maybe legally that's their problem to deal with, but it can cause problems for you if you hold this data that's been maybe obtained illegally. So do some digging into the companies and service providers who are providing you with this data and try and understand how it's actually been obtained, how it's been obtained, that can be quite relevant. So yeah, the question is, of course, right, should we do passive or active? And of course, yes, we should do both. If we look at, the benefits of doing both approaches is that you get a really broad perspective, right? You get a broad picture of the OSINT profile of your target. So, you can kind of see, okay, well, this system told me this about this target, and this system told me that, and I actively collected some information here. And by getting that complete view, you can actually start to spot some really interesting things. This is something I actually kind of discovered by accident in SpiderFoot years ago, is that customers were using the cloud-based service, and they were running like getting the data, and I was doing some calls with them and showing them like, okay, well, this might be interesting, this might be interesting. And, we spotted that actually, like, if something appears only a couple of times, it's kind of weird and it might be worth looking into. And we actually developed some functionality to automate this. So we could actually see, for example, you would scan a target and you would see from that target that, they had mostly AWS infrastructure, but then they had this, couple of Azure machines, or they had these couple of like DigitalOcean machines that were part of their domain. Well, that's kind of weird. Or it's IIS-based infrastructure, but then you see a couple of Apache or an Nginx, systems. So this often revealed things like shadow IT or legacy systems that had not been migrated or forgotten. And you could often only achieve this by getting this broad spectrum of OSINT, right? Because you're querying not just active data sources, but maybe passive data sources that have data that's a bit older, or before the systems were placed behind a load balancer, this type of thing. It could be extremely revealing. And then dependencies is a really key one, right? I think, yes, APIs can change. They can be buggy and they can have availability issues. That's something key to note. So when you're writing any tooling, it's important that you don't draw conclusions on OSINT that may have been failed to be collected, right? So what I've seen is, and I've been guilty of it myself, is that you collect some data, and you say, okay, like, I found email addresses, I found names, whatever. Okay, this looks great. But what you didn't realize, because you didn't look at the logs or you didn't see the failures, is that maybe an API was down, or maybe querying a particular system failed for whatever reason. Maybe DNS failed because of throttling or whatever else, and you actually missed a whole ton of OSINT. And so it's very important to keep an eye on what your dependencies are and how they might be failing. And even if you're using APIs that provide SDKs, they can also change. The dependencies of those libraries and SDKs can change. If you're upgrading your system, and this is where Docker becomes very, very important. If you're running just natively on a Linux machine and you update, SSL libraries or something like that, that can actually break a whole bunch of stuff that used to work. And then, suddenly you're not getting results, but it's not obvious as to why you're not getting results anymore. Of course, security updates need to be applied, and that means, again, with the maintenance, it's important to keep that top of mind. And you are processing untrusted data. So with OSINT, yes, if you're querying APIs, probably it's more trustworthy to some extent. If you're querying the target directly or other systems, you are getting untrusted data, right? Like you're fetching data from a web page. You don't know what's in that web page. If you're executing JavaScript, for example, from those web pages, you don't know how trustworthy that is. You don't know whether the website's been compromised to serve malware and so on. So you have to really keep in mind data you're getting is untrusted. And infrastructure can be unreliable, so you really have to cater for failures. DNS, for example, like you will have issues with DNS. You will get blocked and filtered depending on how high a volume of automation you're performing. You will be throttled by probably the API service that you're querying. That is quite a common case. Resource constraints, which you may face on your own machine or on the upstream that you're querying. And one good example is with whois. So you can run a whois query. It's probably difficult to see here, but this query succeeded, right? I just ran a whois in my machine, ran it against the domain name, got the data back, everything was good. Ran it 5 times later and actually got an error message from the whois server saying, I've hit their limits. Now, if I have automation around this, and I'm not checking for this error and I'm not seeing that this is happening, I can draw false conclusions. So it's really important to keep an eye on that. And of course, you can be blocked. This is something that hit me quite a few times when I was running SpiderFoot from my home network against malicious IPs and botnets and things like that. I got a letter here from my ISP basically telling me that they'd spotted suspicious activity and that I should check my logs. I should install, of course, antivirus. And it requires some communication with my ISP to tell them that I'm doing security research, and it's fully expected that I'll be communicating with malicious IPs, and it was all fine. Luckily, they didn't block me, but I think they were just a couple of steps away from doing so. And I wish I could say the same for my cloud provider at the time when I was running, also scans on the infrastructure that I had SpiderFoot running on, and the stuff was just immediately suspended. And probably for good reason. I think they suspected that, that there was some infection on my machine because I was communicating with suspicious IPs. But again, it was as a thing that something just completely shut down, and I had to really go back and forth with the provider to understand, okay, why and what can I do to prove to you that this is all legitimate, etc. So I know a lot of cloud providers do this these days. You can kind of give them a heads up and say, I do vulnerability scanning, or I do this type of stuff. And it's to be expected that you might see suspicious activity, but it's okay, I'm legit. Good. So entity extraction. So this is, just to remind you, this is where we're talking about getting data and extracting data of interest from that data, right? Like IP addresses, names, and so on. And thankfully, we have regular expressions. So I would really emphasize the value of learning regular expressions. I know if you look at them, they look like jargon. It can be a bit of a learning curve, but once you get on top of the regular expressions, they can be incredibly useful. Just to identify an IP address, name, email address, or subnet, super useful to just kind of have these regular expressions. You can apply it on a large data set, and you can extract everything and it's basically pre-structured for you. And then when you've got that, then you can move on to the next stage of your automation. So incredibly valuable tool to have in your arsenal. And I would say, okay, yes, regular expressions doesn't save you all the time, right? So some things you need to have maybe third-party data lists that you can supplement your regular expressions with. For example, there's a public list of top-level domains. So you can maybe use a regular expression to get out things that look like host names, or web host names on the internet, and then maybe supplement it with this to extract ones that are real host names, right? Ones that are on actual top-level domains. But then, of course, we run into limitations with regular expressions, and that's the real world, right? So the real world is when we start bumping into things like names. So let me explain to you what I mean here. So my name is Steve McAuliffe. It's my regular name. But of course, I have a legal name, which is actually Stephen McAuliffe. And I don't like when people call me Stephen, so don't call me Stephen. And then I have a full name, which is even worse, which is Stephen Charles McAuliffe. And then I have, of course, I can be represented as with a middle initial, so Stephen C. McAuliffe, and then abbreviated S. McAuliffe, SC McAuliffe, and then having it ordered differently, so McAuliffe Steve, or titled Mr. McAuliffe, Mr. S. McAuliffe, Mr. SC McAuliffe, titled in a different language. In Switzerland, I'm often referred to as Herr McAuliffe. And of course, then, we haven't talked about like all these different representations, but in different character sets, different languages. So you can imagine when you're trying to automate something which seems as simple as extracting names from some data, it can get very, very complicated. And this is something probably for the realm of machine learning, AI, but it's far from something that you can achieve with some basic scripting or regular expressions. And something that you think, okay, is a bit more structured, right? Like addresses. Maybe addresses are an easy thing to pass out, because after all, I can probably send mail to some other part of the world and it probably will get there. But again, we have a similar problem. We have, this format here is in Spain. And then we see this format in Greece. And then we see this format in Australia. Looks a bit similar to the one in Spain, but we'll see the number is actually in the opposite direction. Then you have the United States, where you have a state code typically, and followed by a postcode. You have Japan, where again, like it's looking different. You have maybe a number, and then a street name with some numbers, and then it gets even more complicated. You have London, which has a different postcode format. In Berlin, again, in Germany, and typically also in Switzerland, the street address format will be different as well. In India here, this is, we have no street numbers or anything like that, just names. And in Seychelles, I mean, yeah, this is, again, very, very different. So even if you think, okay, well, an address is standard, it should be fairly easy to pull out, it's also incredibly difficult. So now in terms of processing, this is where we start getting into the realm of doing something with the data, right? We've pulled the data down, we've extracted like all the entities that we want to do something with. Now it's time to actually do something with that. And the first example I want to talk about is iteration quickly. And iteration is really about, you've got your entities, maybe you've got some email addresses and IPs, but maybe you want to do some processing of that to actually then find more email addresses and IPs. And this is an incredibly difficult problem, which still is not fully solved, I think, with many systems I've seen, is kind of finding that right trade-off between false positives and missing data. So to explain what I'm talking about, like we start off with a domain, let's just say like abc.com. But then we say, okay, we want to find like, okay, what are the host names on abc.com? Okay, we find ns.abc.com. Okay, that's in scope, it's on the same domain name, all good. And then we say, okay, like ns.abc.com resolves to this IP address. And from that, we can also do some kind of like brute forcing and see that we find, okay, like ns2.abc.com. But then if we look at the IP address, we see actually that IP address is on godaddy.com. That's not in scope. We don't really care about like then going to further explore godaddy.com. So we should probably consider that out of scope. And if we look at ns2.abc.com, that's on a different IP range altogether, but it's still part of the network scope of what we care about, most probably. But if we say, okay, if we use that same logic around GoDaddy, that, okay, it's a different domain, so we don't care about it. What about when we see we have abc-z.com, and we see that actually that is a completely different domain, but it's still actually relevant and part of our scope. And then, of course, from the IP address, we find that, okay, these host names are in scope. We do care about them. So that's a difficult problem. And then I would say also beware of data sources with very few or no quality gates. So planning fake OSINT is not difficult. Be aware that like just because you find like socialmediaplatform.com/Starbucks doesn't mean it's actually owned by Starbucks. Likewise, you see berlin.domain.com doesn't mean it's in Berlin. Anyone can create these entries. There are very few quality gates that prevent someone from actually creating fake entries here. Time is a critical dimension. IP addresses, phone numbers, addresses, they change over time. They might not be owned by who you think they're owned by. And many people share the same name, right? So my name, if you just Google me, yes, okay, they're all a bunch of bald guys, but they're in different fields. You have one UFC fighter, you have myself, you have a tax accountant. It can be very misleading. Probably even ML will get tripped up by this. So my answer to this is basically, bring automation together with humans, right? So present humans with data and give them the tools to work through that data. Always have a human in the loop, in my view. Make sure that human understands the nuance of the domain and knows how to work in the domain and the challenges there and where they can get tripped up. And always ask yourself, what are the quality gates of the data? Understand what it is that makes the data accurate or potentially false. And of course, check the bias. I mean, that could be a whole presentation on its own, but making sure that you're not already starting out with a preconceived notion about something about your target, and then just looking for evidence to support that claim. Getting close to wrapping up now, I would say, check out these tools. Yes, I mentioned SpiderFoot, but there's a bunch of other great tools here that automate a lot of this work and make life much, much easier. Try not to reinvent the wheel. That is one big lesson learned. A lot of these tools do a lot of great work. And I would say, just to summarize now, just to kind of recap everything, on the tech side, if you're starting out, please give Linux, Docker, and Python a go. Consider how you'll maintain the technology that you're building. On the data collection side, I think using a combination of passive and active techniques is the way to go. Getting a broader collection of data will help you spot outliers, and outliers are extremely interesting from my perspective. And understand and manage your dependencies, making sure that you check for errors, check for failures before drawing conclusions. And avoid running locally on your own computer, but if you are going to run it in the cloud or a server or something, give your ISP a heads up to avoid getting blocked. In terms of entity extractions, regular expressions, can't go wrong. Real world stuff is hard, don't underestimate it. I would say, with the processing, iteration is an incredibly powerful tool, but it needs scoping. And this is where getting the human in the loop is incredibly important. Understanding the quality gates is also very important before you're drawing conclusions about the validity of data and attributing that data. Keep the human in the loop. I think can't emphasize that enough. Leverage existing tools to avoid reinventing the wheel and save yourself the headaches that other people have already gone through. And that's about it.